take a look at number 24. Adding and subtracting rational expressions with different denominators. And let's refresh our memory on the steps. Adding, subtracting rational expressions with different denominators. Our first step, get rid of parentheses on top. Numerator. Step 2, factor all the denominators, the bottoms. Step 3, find the LCD, least common denominator, and rewrite each fraction with that denominator. Step 4, add or subtract the top parts and put into a single fraction. Step 5, factor the top. Bottom should already be factored at this point, so that's not a huge deal. You should have done that on step 2. And 6, cancel if possible. So let's go through these steps for this problem. So we got 6 over x squared minus 17x plus 72 minus excuse me, 5 over x minus 8. First step, get rid of parentheses on top. Don't have any parentheses on top. Step 2, factor all the denominators. This is the PSD method here. With the PSD method, the reason why it's x squared x, no x, and there's no number for the x squared. We take the number at the end, the 72, and we're going to create 3 columns. Product column, we list all products, gives us 72. 1 times 72, 2 times 36, 3 times 24, 4 times something, 18. 5, no, 6 times 12, 8 times 9. S column, we add these numbers together. 1 plus 72 is 73, 2 plus 36 is 38, 27, 22, 18, 17. Difference column, we subtract them. 72 minus 1 is 71, 36 minus 2 is 34, 21, 14, 6, and 1. Number we're looking for is the number in our middle term, which is 17, which is right here. So we're going to use 8 and 9. Now the larger number in our P column, which is a 9, is going to be the same sign as our middle term always. Middle term is negative, so the 9 is negative. Now the number has circles in the S column. S for same signs. So since 9 is negative, then the 8 will be negative. Step 2, factor all the denominators. Now step 3, find the least common denominator. Rewrite each fraction with that new denominator. Well, how I do it is I look at each factor. For example, look at the x minus 8. I'm looking for the greatest number of x minus 8s in any single denominator. There's 1 here and 1 here, so the greatest number of x minus 8s in any single denominator is 1. Then I go to my next factor, x minus 9. I'm looking for the greatest number of x minus 9s in any single denominator. There's 1 here, none here, so the greatest number of x minus 9s is 1. And that would be our least common denominator. Now I want to rewrite each fraction with that new one. This one already has it, so I'm fine there. On this one, it had an x minus 8 down here, which is still down there, but we put an x minus 9 right beside it. So we had to put an x minus 9 right beside the 5. Whatever you multiply by the bottom, you multiply by the top. So then 5 times x is 5x. 5 times negative 9 gives us negative 45. And step 4, add or subtract top parts and put into a single fraction. If you have a negative in front of your fraction, that negative is going to flip the sign of all the terms on the top. So when we merge this together, we're going to have 6, and then the 5x becomes a negative 5x. the negative 45 becomes a positive 45. Well, if I combine together some like terms here, got negative 5x, 6 plus 45 gives us 51. And I'll multiply the bottom parts together. X times x is x squared. X times negative 9 is negative 9x. Negative 8 times x is negative 8x. Negative 8 times negative 9 gives us positive 72, which gives us negative 5x plus 51 over x squared minus 17x plus 72. The reason why I multiplied those back together is for this particular test bank this came out of, they do that for the answer. So we got negative 5x plus 51 over x squared minus 17x plus 72. Looks like A is our answer. Now other books will leave it separate like this. They'll just go ahead and leave it as x minus 8 times x minus 9. So keep that in mind.